Hi everyone. The title of our work is Generating and Controlling Diversity in Image Search. I am Mehrab and this work has done in collaboration with UC San Diego and Adobe Research. So in today's image search platform, if we search for certain queries, especially for a certain profession, the results can be biased towards certain race and gender group. And this can be a problem if you want to show diversity in the top results. The related work in this domain has to do with re-ranking, but this cannot introduce diversity or change distribution, so we need a solution based on generative model. So in this work, we propose generating and controlling diversity by attribute controlled high quality image generation. There are many challenges in this domain. For example, there is no existing dataset for debiasing image search results. The generated images also need to be high quality, and we also need to overcome the imbalance in the dataset for training such a generative model. To overcome the first challenge, we first collected the dataset using the search queries according to this study, and we collected high quality images for this 14 professions. The raw search results contain typical examples, but there are also some simpler examples which inspired us to build a pipeline so that we can detect. So we first detect the faces and align the faces and crop around the face to get the upper body part, which returns the critical information such as race, age, gender, and we also did some manual curation. We can also annotate the face dataset to classify the facial attributes such as race, gender, and age. And this shows our one example for each of the 14 profession of our newly built dataset, which we call stock occupation high quality or SOHQ. And this shows the statistics of the dataset. And you can see from this table that the dataset is highly imbalanced across different race and gender groups. Now that we have an annotated dataset, we can build an attribute to image generation model. We initially experimented with several state-of-the-arts, but finalized our version with StyleGAN 2 because it showed better results. We also chose StyleGAN 2 because it has the ability to map both macro and micro features, and it can introduce diversity by mixing the latent codes. And it can also generate images at high quality, at high resolution, which is a requirement for our task. This shows our vanilla model, and for more details, please refer to our paper. For training, we I've seen that a large number of pre-training can help the generation process. So we first did some unconditional training to pre-train the network and use this weight. So this shows the impact of pre-training without using the pre-train weight. When we trained on a small data set, it faces a mood collapse, but after pre-training, it stabilizes the training procedure. Now we come to the case of handling class imbalance. There are two simple ways to do that. One is reweighting the loss function, and one other is oversampling the minorities. And these examples show that the difference between two approaches, and we can see the uniform yielded a little bit better results, but the uniform also suffers from overfitting, and it can generate some results with artifacts. To alleviate this problem, we introduced augmentation, and we also used augmentation in our vanilla model for fair compression. So these examples show the results between uniform and uniform plus, and you can see the uniform plus solved the problem of overfitting. And this shows our final model architecture. For quantitative results, we report FID and attribute matching score, and you can see that our model does much better in comparison to others. And this shows some qualitative examples. So with respect to vanilla models, which is FFHQ and ADA, they both suffer from showing less diversity and or either or more gender and race mismatch. As I mentioned before, uniform suffer from artifacts, and our final model achieves a good trade-off. We also did some human study, and our model has been chosen more times than the others. And this shows some qualitative examples of our final model. For more details, please refer to our paper. Thank you for listening.